Okay, so we're going to be going over 1.4 today. And so we're specifically going over number 3 because that's what someone asked to do. So I'm going to go over this number 3 down here. So this is asking, and then if you kind of look at some of your classmates' answers, a bunch of people put some stuff here. So let's see. Ooh, someone put some interesting stuff there. Okay, so there's some interesting stuff that we have to learn about this, and technically we haven't learned that function, and that's what I keep telling you over and over again. And you will learn it, I promise. It's just as it sits right now, you don't have it. So this says if you start with 7 and it's 2 to the x, then you go 2 to the 7th equals 128. To undo that, you actually don't know the words for that. Or the function for that. But what it is you're figuring out how many of the base multiplied to get to that 128. So in words, you're figuring out how many bases to multiply. Another way to put it is, what is the exponent? So I'll just tell you right now, one of the things that you will learn has to do with this function called log. And some of you have already seen it, which I think is fantastic. Let me see, let me find that person. Yeah, it's this person right here. So this person put log base 2 of x, and they did it really, really well. So for those of you who didn't know, I'm just going to teach you this definition really quick. No, you weren't supposed to know how to do it. Ms. Johnson, so what were we supposed to put here? Any kind of definition that gets you to the place of understanding. You can't take the square root of this because it's not squared, right? So let me give you a little bit of definition so that you guys can move forward with this. The way it works is this. If I have some a to the x equals to b, right? This is something that you're super familiar with, right? A second. So a to the x equals to b, which is not showing up. That's not friendly. And that's what the log base 2 of x is. So let me write it here just because it's not working. There it goes. So if you have a to the x equals to b, that is the same as, in a different language, right? This is the same thing as log base a of b equals to x. This is a definition that you have to like kind of understand. Don't worry about learning it right now because you'll see this over and over again to the point where you're like, oh, I get it. So in regular words, what is this thing actually saying? This thing is actually saying, let me stick this in my Ms. Johnson handwriting. So this is actually saying log, how do you put this? Oh man, what are you doing? Okay, this means log, this is how you would say it in English, log base a of b is x. So that's what we're saying. So if you look at this and you say log 2x, I know that didn't, like, this needs to resonate how you say it. So think about this as a different language, right? Here we're talking in log language. Over here we're talking in exponentials. I can literally say the same thing in either language, but it's just a matter of what makes sense at that moment, right? Like who I'm talking to or what problem they gave me. So what it actually means is this. A to the what gives me B. Does that make sense? So A to the what gives me B. That's literally what they're asking you about. Okay, so this should be the same. So if I wrote this over here, and if I was going to be fancy here, let me be fancy really quick. If I'm going to be fancy and write it correctly in my math, no, I'm not going to write it correctly. That little 2, that 2 is little, and he's called a subscript, right? So log base 2 of x equals some number. So that 2 is little. He is not at the same level. He's a subscript, as opposed to this exponent up here is a superscript, meaning above. This is a subscript, meaning below. Does that make sense? So log base 2 of x. Log base 2 of x. So this thing is actually asking you, just pretend it says y. This thing is actually saying, now if you take it over here, 2 to the what gives y. That's all they're asking. Okay, so this is the inverse function of this. These two are inverse functions of each other. What does that mean, Ms. Johnson? They undo each other. So exponentials versus logs. It's his real name, his real proper name is logarithm. Logarithm. So when you're looking at these two inverse each other, just like multiplication and division, just like adding and subtracting, just like squaring and square rooting, they inverse each other. You'll see this enough. So I just wanted to give you a little, here's something to think about while we go through all of these inverses. You will see more of that later. Okay, so just don't worry about it for now. Just if you didn't put this as the correct answer, I'm showing you right now to put that. And if you don't know how to type it, let me show you. Click here, click anywhere here, right? So when you start typing log base 2, it's going to do that. So I don't like this at all because that's not what I did. So what I do to get that bottom one there is I go to Desmos and I go to the graphing calculator and I want to type log base 2. But see, my 2 is in the wrong spot. So I'm going to go over here to the keyboard over here, and I'm going to click this. So do you see how now it's a little 2 down there? But now I have this big 2, so I want to get rid of the big 2. That makes sense? And of x, make sure that x is sitting right there. This is what the curve actually looks like. Remember when we were doing that the other day, and you guys are like, Ms. Johnson, can we actually graph the inverse of 2 to the x? And I said yes, and I hid this function. Well, there it is. His name is called log. It's just a new function. This year in Integrated 3, you will learn one new function. Next year, if I don't know what class you plan on taking, if you were to take calculus, you would learn 2 new operations, taking the derivative of something and its inverse, which would be taking the integral of something. Okay, so in math, you're just learning new functions all the time. And so your new function for this year is going to be log base 2. Does that make sense? Okay, so for those of you who are like, oh, Ms. Johnson, I've never learned log base 2. That's correct. That is the job of us to learn this year. Okay, so for those of you who are like, Ms. Johnson, I didn't know that. Now you do, and start writing it down. Do I expect you to produce this on your own? No, not yet. Okay, Ms. Johnson, is this going to be on the quiz? That's a good question. I should look. Hold on, let me look. You guys are like, Ms. Johnson, the quiz is there. Yeah, it's available, but you're locked out of it. So let me see. No, 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 no. 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 Kind of. All right. So the only question that I ask about it could be answered by this, what you see right here. That's all you need to see. Okay, I'm not asking you to find the values of anything yet. That's not our job. Our job is just to know who is the inverse of 2 to the x. All right, so I'll wait for a little bit in terms of questions. Let me post the next question. So problem number 6. Problem number 6 is the next question. Looks like it's here. Yeah, this is the next question. It says, and I just picked someone random. It says, find the inverse of this. So you start with 7. What happens with 7 is you subtract 3 and then you square it. right? And so if you paid attention to the way I was explaining how to find the inverse of before, we had talked about like the present idea, right? Like I put the pen in the box, I wrap the box, I give you the box, you unwrap the box. It's everything that I did in reverse order. So here, if you were to like, hey, Ms. Johnson, how do I do this? One of the ways that you could do this is by switching and solving. The other way to do this is if you just think about what order is happening to that 7. So the first thing that's happening to that 7 is it's being subtracted by 3. The second thing that's happening is once that is subtracted by 3, now we're going to square it, right? This is not new information. You know how to solve an equation. But now if I wanted to find the inverse, you're really just doing the same thing as before as solving. We're going to go in reverse order and we're going to take the inverse of that. So what does that mean, Ms. Johnson? I'm going to undo squaring it, which how do you undo squaring it? In the chat, can you tell me, how do you undo squaring it? Yeah, you square root it. Very good. So here's my x. I'm going to square root it. And then, okay, so I did that, check. And then it says deal with subtract 3. But how do you undo subtracting 3? How do you undo subtracting 3? Exactly, you add 3. Thank you. Thank you, those of you who are participating in there. So then I'm just going to write this as f inverse of x is equal to this. Okay, this result would come out this same exact way if you take this. Let me take this over here. So if I say f of x equals to x minus 3 squared, and then I'm going to switch and solve it. So this is going to say y equals to x minus 3 squared. So now I'm going to switch. So x equals to y minus 3 quantity squared. So then I say, okay, I need you to solve for y. So here, this is going to be me solving for y. So, oh, Ms. Johnson, I know how to get rid of it. You'd have to get rid of that squared. Okay, then we'd square root it. Oh, that sounds familiar because that's exactly what we did over here. We square rooted it, right? We square rooted it. Okay, so square root. So then we get square root of x is equal to y minus 3. And then how do you get rid of subtract 3? How do we get rid of subtract 3? Oh, we add 3. So really you're doing the same thing. So which way do you prefer? Do you prefer thinking about it and then going in a list order? Those are for my people who like to cross things off the list, right? And you would get the same exact thing. So this is a little bit delayed, so I'm just going to ignore that. So you would get the same exact thing. So y is equal to the square root of x plus 3. Don't be sloppy. I know that most of the things that we're going to be doing is going to be typing. Notice here my square root stops right here. Notice here the square root stops right here. It doesn't pull over. So Ms. Johnson, does that make a difference? Yeah. Let me take these off. So what does the square root of x plus 3? Does that look different than the square root of x plus 3? So visually, they look different. So you got to be very careful and very precise, right? These two are very different. So to the, I don't know, to the 3rd or 4th grader, they're going to be like, yeah, that's the same thing. But to you, these should be very different things. And look, the green curve looks way different than this, I don't know, bluish purplish one. Does that make sense? So just kind of keep that in mind. Keep that in mind. So 6 done, 8. So same thing goes here. Now you know how to undo square root and undo exponentials. Now you know how to undo exponentials. So this one's actually wrong. Let's see if I got a right answer. Yeah, this person listed out, I really like. They said add 10, then log. Very good. So this person's list is perfect. I'm going to show you how to actually write that. So let's do this one. Okay, so for this one, I'm actually going to solve it just so you guys see that you can list it out. He already, this person already listed it out for you. So if you were thinking about it, you'd say, okay, well, what did this person have to do first? So they had to exponentiate, exponentiate. That's the verb form of exponential. And then number 2, then you subtract 10, yeah? So same thing goes over here, right? You're just gonna reverse that order. So number 1, you're gonna add 10 to both sides, and then you're gonna take the log of both sides. Let's see if we can do that. There it goes. So f inverse of x would look like, get rid of the negative 10, so that would be x plus 10, right? And then you'd have to take the log, but you're not just taking the log of x. So I'm going to put parentheses, super important parentheses around this. And I'm going to put log. I can't just put log. Things that you'll know later on is that when you write log here, there's an invisible base of 10. We'll talk about this later, but just for now, this is a base of 2. Ms. Johnson, will we have to know this part for the quiz? Doesn't get this intense. Okay, so you should be okay with this. Looking at this, looking at what operations were had, and then you undo that. This person did it perfectly here. So this answer is completely acceptable if that's what you wrote. If you're trying to take yourself to the next level, this is what you will be learning pretty soon. This is like me letting you peek into a couple units ahead. Okay, number 10. It says in number 6, could any value of x be used for f of x and still give the same output for f inverse? So going back to number 6, right? We're looking at this guy here. Ms. Johnson, can any, what was it? Say it again. So if it could be any, let me see where this is. Number 10. Okay. If number 6 could be any value of x, so now look at number 6. Here's number 6, right? Any value of f of x and still give the same output for f inverse, could that happen? And so then I'm going to turn your attention to these 2 that I did not get rid of. Right? And the answer is yes, right? The answer is yeah. I could take any input and reverse it and it'll be the exact output. So this is basically asking you, hey, is it invertible? Is this invertible? And the answer is yes, right? So if you remember, the way we tested the function was by looking at the horizontal line test on the original function, right? And because the original function passes, then that means the function, the inverse of that function is a function, which again, then you can just check it using your vertical line test. And remember, we talked about this asymptote nature. Even though it looks like it's going to be a vertical line, it's really not. As you get closer and closer, you can see, as I zoom in, it's getting closer and closer, right? But it also has this curve to it that it's getting, going along this, it's getting actually smaller on the X side. Okay, so just kind of keep that in mind. So that answer is number 10 for that one. Your exit ticket. I think you can.
I have a quick question.
Yeah.
For the square, would the square root include the x and the 3 or just the x?
This one right here?
Yeah.
Yeah, no, it's just the x. So if I turn off, this is a really good question, by the way. You're asking, Ms. Johnson, are these the same? And I'm saying, no, they're not. And you're saying, okay, Ms. Johnson, which one is it? It's actually this one. This one, right? The reason why is because we add the 3 after we square rooted it. We add the 3 after we square rooted it. As opposed to this one, right? We added 10 and then we took the log, meaning I had to take the log of that whole thing. Does that make sense?
Yeah, thank you.
Awesome, good question. Okay, 10 done, exit ticket, Ms. Johnson. Find your exit ticket all the way down here. Okay, so your exit ticket looks like this. It says find the inverse of each function. You should be pretty proficient at looking at this and thinking about the inverse functions. So I'm gonna not do it on there because I don't have to go back and forth. Wait, just let me, I like looking at what you guys do. Hold on a second. Where's my exit ticket? So let me, what I like doing is I like showing you this and being like, all right, would you give this person a perfect grade on the quiz? So keep that in mind as I do this, because then we'll come back to this and pretend that you are the teacher and you have to grade this person in order to do this, okay? So for A, Can you tell me what happens first? What would I have to take care of first in the chat if you can? What would happen first for A? Sorry, yeah, exactly. So the very first thing I have to take care of is if you're listing out those things, that it's being multiplied first, right? Someone said, hey, Miss Johnson, can we switch X and Y? Exactly, that's another thing. So I'll write switch right here. And then, so I'll go X equals to 2/3 Y minus 7. This is, again, one of those things, right? This is one of those things that I want you to practice. So for those of you who are like, Miss Johnson, this doesn't make any sense, good thing that it doesn't make sense today as opposed to next time we meet, which is your quiz, right? And then the second thing that I want you to do is solve. So for the person over here, and they're listing out what happens, see, first it multiplies by 2/3 and then it gets subtracted by 7. So when you're thinking about what happens first in order to solve it, well, you take care of this guy first. You undo the subtracting 7. Very good. Thank you in the chat. I appreciate that. So then I'm going to add 7 to both sides. Very good. So then we get X plus 7 equals 2/3 Y. Okay, so then, hey, Miss Johnson, I took care of the minus 7. Now what do I do? Well, now you have to get rid of times by, oh, sorry, this is 1, this is 2. Then what I want you to do is times by 2/3. How do you undo multiplying by a fraction? How do you undo multiplying by a fraction? So the question I'm asking, and then so for those of you who are trying to study for your quiz, you're trying to answer all of my questions throughout the when I'm teaching you. So if you're sitting there and you're like, Miss Johnson, I don't understand anything, just start answering a question, right? Just start answering. It's okay if it's wrong. It's okay to say, I don't know, because then you're telling your brain, I don't know something. And your brain, because it's naturally curious, as long as it's still curious, it'll say, okay, well, if I don't know, what do I do? Exactly. I have 2 different answers in the chat, which are both true. One person said to divide. That makes sense because to undo multiplication, you divide. And someone else said multiply, very good, by 3/2. And if you remember back in 6th grade, when you divide by a fraction, you're really multiplying by the reciprocal. So both answers are legit. I will just automatically do this one for you. So I'm going to multiply by 3/2. Multiply by 3/2. If you noticed, I put that whole guy in parentheses, right? Why did you do that, Miss Johnson? Because if I only multiply the X by 3/2, these two will not be inverses then. So these parentheses here is saying, I want the whole thing. I need to multiply that 3/2 by the whole thing. The whole thing, Miss Johnson? The whole thing. Okay. So what happens, Miss Johnson? Well, the 3's divided by 3 is 1. The 2 divided by 2 is 1. I get Y equals 2. Miss Johnson, do you want me to distribute that out? No. Leave it like that. Miss Johnson, could I distribute it out? Sure. Absolutely. Do I want you to distribute it out? Not really. Not really. I am a math teacher. You are all mathematicians. You are trying to find the most efficient answer. This is a pretty efficient answer. So this is my F inverse of X. F inverse of X. F inverse, that little negative first, is inverse. F inverse of X. Okay, one of the things that you were supposed to learn from this section here was how would you check this answer? I love knowing how to check my answer. Checking my answer is very important to me because that means that Miss Johnson can't take any answers away. Does anybody remember how we check our inverses? How do we check our inverses? Take a drink of my coffee. It's okay to say, I don't know. And in fact, if you don't know, put I don't know in the chat. Actually, Emily, good answer. Horizontal line test. That checks if your thing is a function. I'll give you 2 different ways to check your answer. but I need to see more I don't knows. Thank you, Alyssa. Awesome, Matthew. Okay, first way, easy way, is go back to Desmos. Ms. Johnson, are we allowed to use Desmos on our test? Yes, please use Desmos on your test. So I'm going to graph this function right here. So y equals 2/3. I don't want to be on the bottom. So x minus 7. You all see my line right here? Very good. I'm going to graph this one. What should happen when I'm done graphing this? What should I see? I don't want it there. I want you up here. What should I see? Anybody know what I should see? I'm typing it in slowly so I can, what should I see? Okay, if you don't know, let me show you what you should see. I'm gonna zoom out a little so you can see. Anybody want to describe what you could see? What should you see when you graph inverses on the same? Yes, yes, very good. So someone said, Ms. Johnson, should it mirror itself? Yes, it should mirror itself along the y equals x line. Here's your mirror. Imagine me folding my graph along this line. You see how this matches with this? Earlier, we talked about how, I need to find a good point. Where's a good point? Where's my good point? That's a good point, but that one they share, so I don't like that one. 0, 7. So here's 0, -7, right? That's this guy's y-intercept. If that's correct, I should be able to switch, because that's what inverse means. I should be able to switch x and y, and I should get -7, 0. If I push on this and it says -7, 0, that's what I want to see. Ta-da! I'm so excited, Miss Johnson. This is right. Okay. Way number 1. Okay. Way number 1. First way is to check to see if your points are mirroring, or as one of your classmates said, it's reflecting across this line here. It should mirror itself. So visually, this is what you should see. So if you're trying to figure out, Ms. Johnson, how will I know that I'm ready for this quiz? I should be able to ask you something and you should be able to tell me about it in a picture or prove it algebraically. But if you're really trying to get an A, it's both of those things, okay? So here's the picture. The other way, so your picture, the other way is to actually plug them into each other to see what you get. Okay, so here's way number 2. Way number 2, this is me checking it, check. And I'm not going to check every single one, but I want to make sure that I show you. So I'm going to do this, and you should understand what I mean by this. This looks like a mess, but it should make sense, okay? This should look like a mess, but it should kind of make sense to you. So here I go. So I'm saying if I take f inverse and plug it into my function, so I'm going to take this guy, Ms. Johnson, and I'm going to plug it into that x, and then I'm going to do vice versa. I'm going to take this and plug it in here, and they should all equal to x. You can't do one without the other to check if they're inverses of each other. Does that make sense? So I'm going to do that really quick. So I'm plugging f in, so that looks like this. F is 2/3 something -7. So then I'm going to plug this guy in here. So that's 3/2 x plus 7. What do you already see happening? Oh, hold on. It's thinking. So you should have this 3/2 x plus 7 in here, right? What do you already see happening right here?
They're gonna cancel out.
Yes, and I forgot my parentheses. Do you see this parentheses right here? I forgot them in here. I'm going to add them because if I don't, then I'm going to mess it up. Yeah, I already see the 3/2 canceling each other. I tend to not like the word canceling just because it doesn't go away poof like magic. It actually just multiplies to 1. Do you guys all see that? So this multiplies to be 1. 3 divided by 3 is 1. 2 divided by 2 is 1. So here I have x plus 7 minus 7. Anybody see anything else happening? Oh, It's catching up. X plus 7 minus 7. What do you think is going to happen here? Right? That equals to 0. So this is just left with X. So far, I'm good. Yay. So far, so good. And then I'm going to do vice versa. I'm going to take this guy as my outer function and plug this guy into him. So far, because this is X, I'm like feeling really good about my quiz. Oh my gosh, Miss Johnson, she can't take away points here, right? Continuing on. Let me do this in a different color. So this one goes here. So the outer function is going to look like this, 3/2. And then here's my parentheses, and then plus 7, right? 3 has X plus 7. Okay, let me let that catch up. And then I'm going to take my original function, and I'm going to take them and plug them in right there. Sorry, I'm going to like zoom out a tad so you can see. So I'm going to take this and plug it right in here. All right, so you want me to do that, Miss Johnson? Yes. So 2/3 X plus 7. You should already see what's gonna happen, and I copied it wrong. It's minus, Miss Johnson. You should already see what's happening. Minus 7 plus 7. You guys should all see this, but you can't because my computer's going slower than I want it to. Hold on, let's see. Yay, there it is. Okay, sorry, I'm closing out all my crazy apps. Okay, so now you see that the minus 7 plus 7, yes, exactly. Thank you very much. Thank you very much for participating. I see you in the chat. Yes, so those two cancel, minus 7 and plus 7. What happens next? If that goes away, what would happen next? Okay, so then I have 3/2 times 2/3 X, right? Because this and this canceled. So then those two cancel out. Oh, it's really slow right now, sorry. So these will cancel as well. Let's see. Yay, it's working. All right, let's make it go faster. Okay, so these will cancel as well. Or I should say they divide out to be 1. So this is just X. So that's a check. Once this simplifies to X, you plugged in the function to the inverse and the inverse to the function, and they both equal to X. These are guaranteed. Ms. Johnson can't take away any points. You've even checked your answer. And in fact, you guys checked your answer in 2 different ways. Ms. Johnson, can I check my answer on using the graph? Yeah, but you just have to explain what you did and what you saw. That makes sense? All right. So B really quick. Miss Johnson has to hurry up. B really quick looks like this. So I'm going to just write y equals to 2 parentheses x minus 1 squared plus 3. And it says to find the inverse of each function. If you remember stuff about our inverse and our squared, you should be remembering something. You should be remembering something. So I'm going to graph this really quick. So y equals 2 parentheses x minus 1 parentheses 2 this squared plus 3. Did I copy that right? 2. Nope. This is minus 1. 2 parentheses x minus 1 squared plus 3. Okay. If you notice this, something should be popping out to you right now. Something should be popping out to you. I'll give you a little hint. Looks kind of like this when I do this thing, like, what should you be thinking right now in terms of inverses when you see a picture like this? What do you think? And if you don't know, no worries. No worries. So this function is a function. I agree with you. But the question is the inverse a function? Is the inverse going to be a function the way it looks right now? Like if I reflected this across and I get some picture that looks like this, right? Yeah, it's not a function. Very good. It's not a function because who remembers why I could tell that this is the inverse of this is not going to be a function? Why is this not going to be a function? Yes, you guys are so good, but can you please tell me in the public chat, not just the private, because then it looks like I'm talking to myself, right? Okay, so a lot of people said, Ms. Johnson, this fails the horizontal line test. And if you remember the horizontal line test, write it somewhere. The horizontal line test, actually, if you could put that in the chat, the horizontal line test tests if the inverse is gonna be a function. And notice it fails, right? Look, fail. Let's try up here. Fail. Okay, so right here, you're gonna see that it's not gonna be a function. So we're gonna have to restrict the domain. Can someone put that in the chat so I can copy it right here so I don't have to type it out? Can someone put, because it fails the horizontal line test, in order to get an inverse, I'm gonna have to restrict the domain. Okay, go ahead and do that. Give me a second. I need to grab something. Hold on. Like something fun. There you go. Thanks, bud. Okay. So, okay. Hold on. Horizontal line test. You're fine. Okay, so let's put that here somewhere. I'll put my big crazy notes over here so that whenever you're looking for them, it's always going to be in that area. And then I'll highlight it. Okay, so the horizontal line tests if the inverse is going to be a function, and then if it fails, that means you need to restrict the domain in order to get a function. Does that make sense? You have to restrict the domain. I'll explain what that means in a second. But for this one, it restricts it for you, so you're okay. So again, I'm going to kind of rewind slowly. So your brain, now that you understand this, right? Oh, wait, sorry. Does the vertical line test also, wait, does the vertical line test if the inverse is a function? Yes. The vertical line test, you can always use the vertical line test. Whenever you're using the vertical line test, you're checking if the thing that you're looking at is a function, versus the horizontal line test over here says the horizontal line test tests if the inverse guy is going to be a function. So when I look at this, if I said, hey, Ms. Johnson, can I use the vertical line test on this? I say, yes, absolutely. So you go through and you're like, Ms. Johnson, it passes. It passes, but what does that mean, right? When it passes the vertical line test, this green function, you just said, check, right? Check, it's a function. Yep, it's a function, Ms. Johnson. Perfect, right? So for those of you who are like, okay, but Ms. Johnson, what is the horizontal line test? So the horizontal line, hold on, let me get over here. The horizontal line test if the inverse is going to be a function. This is perfectly written, whoever did this, thank you so much. So now I'm going to do the horizontal line test and I'm going, oh no, you failed. So because it failed the horizontal line test, it doesn't talk about the function itself. It's talking about this guy's inverse. The inverse of this, the domain is going to be different. So when you see, when I reflect this, it's not going to be a perfect reflection, and you'll see, and then you'll understand, oh, that's what she means by restrict the domain. Okay. So kind of moving on, I'm going to switch and solve. So here I'm going to switch. You guys are getting better at switching. So notice, for those of you who are like, Ms. Johnson, finding inverse is totally new. Kind of, but not really. right? You switching variables, that's not new. X equals 2 parentheses y minus 1 squared plus 3. And then you solving is not new because you've been solving equations since you were in 6th grade. What's new here is you're finding a function based on another function and telling me what those two things mean, right? Okay, so for those of you who are like, oh my gosh, this looks like a mess, Ms. Johnson, I don't even know what to do first. No problem. Just look right here and make a list of what's happening to X first, second, third, fourth. All right, so I'm going to go over here and I'm making my list. Number 1, if you knew what X was, what's the first thing, according to PEMDAS, what you would do? If you knew what X was, pretend it's 7, your favorite number 20, I don't know, whatever. What would happen first to X? What would you do? So 20, what would you do first? Anyone in the chat. And if you don't know, say, I don't know, Ms. Johnson. Yeah, no, actually, sorry, no. Pretend, actually here, do this for me. So let's go over here, 2 parentheses, X minus 1 squared plus 3. So let me do this really quick over here. So I want you to pick a number. I just said the number 20. I'm going to choose a smaller number because I want to be able to do that. Yes, actually, someone said it in the chat. So I'm going to pretend my number is 5. So I just chose a random number. If I told you back in, this is probably 8th grade, I need you to simplify this expression. What's the first thing you would do? You would be like, oh, PEMDAS, Miss Johnson. Yes. So go through PEMDAS. I do slashes between multiplication and division because it depends on who comes first, left, right. So what would you do first? You would subtract 1. Okay, so then the very first thing I would do is subtract 1. So then now I have 4 squared times 2 plus 3. So there, I took care of parentheses, right? What's the next thing I'm going to do? According to PEMDAS, what's the next thing I'm going to do? What's the next thing I'm going to do? Yeah, no, sorry. It comes E. E comes next, right? So I'm going to do the exponent. Does that make sense? So then I'm going to do the exponent. So over here, I'm going to put square it. Use different colors, sorry. 2 is square it. Okay, so I'm going to square it. So I get 2 times 16 plus 3. So I did my squaring. Do you guys all see my squaring now? Does that make sense? What's the third thing I need to do? What's the third thing I'm going to do? What's the next thing I'm going to do? Yes, I'm going to multiply. So then I multiply. So that's 32 plus 3. So multiply by 2. And then the last thing I'm going to do is I am going to add 3. Good. So for those of you who are like, I don't even know how to solve this equation, no problem. Do you remember PEMDAS? You're going to do everything backwards in reverse order, and you're going to undo it. So I call it the reverse inverse thing. When you're solving, you're reversing and you're inversing. So literally, Ms. Johnson, I could have taken PEMDAS over here and just followed the order of operations backwards. Yeah. So you're going to SADMEP it, right? You're going to SADMEP it. Okay. But remember that inside parentheses, you got to kind of include that in the very, very end. Okay. So according to this, if you go on SADMEP, the very first thing you're doing is subtraction or addition. Ms. Johnson, how come you don't take care of this one? Because he's stuck inside parentheses, so we can't touch him. Also, if you follow this order, we have to undo the adding 3 first. So you want me to undo adding 3, Ms. Johnson? Yep. We're going to subtract 3. We're going to subtract 3. Hold on a second. Okay, very good. Very, very good. Very good. Okay. So we're going to subtract 3 to both sides, Ms. Johnson? Yes. How come? Because SADMEP told me to do it first, and the order of operations in reverse order told me to do it again. Does that make sense? Okay. Okay, so we're subtracting 3 from both sides. We got x minus 3 equals to 2 parentheses y minus 1 squared. Okay, the next thing we're going to do, according to SADMEP, is look for any multiplication or division. Hold on, wait for it. According to this, I need to get rid of multiplying by 2. How do we get rid of multiplying by 2? Yeah, we divide. Now look, if I was right here and I'm not even paying attention to this and I'm just using SADMEP, the next thing I need to look for is any division or multiplication on that side. Ms. Johnson, I found multiplication. Very good. How do you undo multiplication? You just divide. Very good. So I divide both sides by 2. Okay. So these would cancel and I'm left with y minus 1 quantity squared equals to x minus 3 over 2. Miss Johnson, do you have to put the whole thing over 2? Yes. If not, you're wrong. Miss Johnson, if I don't put the whole thing over 2, will I be wrong? Yes, you will be wrong. Okay. The next thing, I've taken care of sa and I've taken care of dum. So now I'm looking for exponents. Is there exponents on the y side? And you're like, yes, Miss Johnson, I see the exponent. So then we are going to square root both sides. Now, this is the part that you have to remember back in integrated 2, okay? Back in integrated 2 land, and this is where it's gonna kind of be a little bit different. Back in integrated 2 land, right? Whenever you took the square root, you had to include plus or minus, right? You had to include plus or minus. If you don't remember, kind of remember this. X squared equals to 9. What's the solution of x squared equals to 9? Can you put it in the chat, please? What's the solution to x squared equals to 9? I'm just updating my thing. Oh, there it goes. X squared equals to 9. So someone said 3, and I'd say, you're only halfway there, right? Because I'm really asking what number can I put in there to make this true? You found a solution. I need all solutions. So in mathematics, one of the things that we expect you to do is be able to tell us all of the answers. So here we're looking, yes, for another answer, -3. But Ms. Johnson, where does the -3 come from? Well, when you take the square root, you also have to include plus or minus. Plus or minus. Plus or minus. Ms. Johnson, why plus or minus? Because otherwise the answer won't come out. If you remember, this little 2 right here tells you this is how many answers you should be looking for. At most, you should be looking for that many answers, okay? And that's actually in the set of real numbers, but that's okay. So notice here we have 2 answers here, right? Graph wise, if I was asking you the same question, right? If I said x squared, oops, sorry, I don't want s, I meant x. So if I graphed you x squared and I said, okay, I want it to be equal to 9, y equals, sorry. So graph it for me. What I'm doing really is I'm looking for the 2 places where these 2 intersect, right? Right here is one solution, -3. Here's the other solution, add +3. Miss Johnson, how come the calculator, when you put square root of 9, it only gives you 3? Because you told it to only give you the positive answer. And plus, calculators are function-based, meaning you ask it one thing, it can only give you one answer. Notice here, this is a plus or minus. This is 2 different answers. So if you don't remember this, not a big deal, because it's not going to come up for a little while in terms of this class, but I will be reminding you over and over again until then. But for our purposes here, you'll see why this is important. Okay, let me continue. Miss Johnson, here we go. So right here, I can now cancel the squared and the square root. So now I get y minus 1 is equal to plus or minus the square root of x minus 3 squared. I mean, over 2, right? And the last thing you would do is add 1 and add 1. So your final answer looks like a hot mess, looks like this. Okay, if you did not get this, not a big deal, but now you have the correct answer for it, so you can actually see it. Miss Johnson, for us, what, like, can you check that for us? Can you show us how you would check this? Yes, I would actually check this using a graph. I would also check it algebraically like I did over here. I would check it algebraically like I did over here, but because I'm trying to save time so I can get to more of your questions, I'll have you do that. But picture wise, I'm going to graph this. And the interesting thing is if you try to graph plus or minus, this calculator won't do it for you. So I'm going to graph just one side at a time, and then you'll understand why. So let's see, 1 plus the square root of x minus 3 divided by, not like that. I don't like it. So I'm going to put parentheses around this guy. Very good. And I put divided by 2. So the reason why I like Desmos so much is, you see how this looks exactly like this? If you were to do this on a TI calculator, it doesn't look like this. Like you would have slashes and all this other crazy mess. But because this is how I write, this is how they made sure that it shows up for you. Okay. So what do you notice? Hopefully someone noticed, like, oh my gosh, Ms. Johnson, I see something. I see what you see. I understand. Does everybody see it? What do you notice? I'm gonna drink water. Yes, this is the function, but I technically haven't graphed both of them. But if I just graph this part, do you remember, let me turn these off really quick. When I graphed these two, what did you all tell me what I should see? What did you all tell me? Ms. Johnson, you should see blah, blah, blah. What do we see here? It should mirror one another. Very good. If they're inverses of each other because they mirror one another. Okay, keep that in mind. Now look at this. Could you say the same thing about these guys? Do they mirror each other? Everybody says. No, it's not a mirror of each other. So frustrated, right? Okay, so then you're like, wait, did I do it wrong, Miss Johnson? No, you didn't do it wrong. But remember when we took this and we took this and it said you failed, right? That means you had to restrict the domain. That's what we wrote over here in yellow, right? If it fails, it means you need to restrict the domain. So here, I'm going to restrict this domain. Now, I could graph the other side. Let me just graph the other side so that you guys can all see. Equals to 1 minus the square root of x. Oh, I should have just copied. So that's okay. Divided by 2. So now do you see, oh, Miss Johnson, it's a mirror image of each other. And we're like, yes, we did it. Except for, is this a function? Is this guy right here, is he a function? Is this guy right here a function? Answer in the chat says, no, it is not, Miss Johnson. It fails the vertical line test, fail. But you already knew that because you told me earlier, it's going to fail the horizontal line test, right? Very good. Okay, so Miss Johnson, what should we put as our answer here? Okay, so your answer should be this right here. Let me turn this guy off. Should be this guy. This guy right here. So Ms. Johnson, you want me to cross out that negative? Yes. So here, my final answer is going to be F inverse. Is it F? Shoot. Nope, it's G. Okay. So G inverse of X is going to be 1 plus the square root of X minus 3 over 2, right? So notice that square root is including everybody under there, right? So then, Ms. Johnson, doesn't that mean we need to restrict this domain? Yes, you would have to put a restriction on the domain. So you'd say something like, all the numbers greater than this number right here, which I think is 1. Yeah. So you'd say all the numbers greater or equal to 1. You want the numbers to the right, because when you reflect it, it'll look like this. If not, if you use this, the less than sign, then you would have to write this as your thing there. So when I ask you questions on the quiz and I say, hey, is it invertible? You're answering questions like this. Wait. Oh yeah, Ms. Johnson, it's not invertible. And you'd have to explain why, right? No is not a good enough answer, because no, I can text to my friend really quick. Hey buddy, what's the answer to number 4? No, that's very cheatable. Remember, I told you, when I'm asking you questions, it's not going to be very cheatable. Okay. Not cheatable on purpose, right? Okay. Last question, and then we're going to take a short little break so I can have you guys have your brains rest. We're going to do h of x really quick. H of x you should be comfortable with now. If not, no worries. Just get there. We want you to get there. So h of x equals 10 to the x. And I say, okay, find me the inverse. And then you're like, wait a second, Ms. Johnson, you told me about this. Whenever it's like x is in the exponent, you told me about this. And I'm going to scroll up. I'm going to look for my notes. No, that's not it. Oh yeah, it's right here, Ms. Johnson. So if x is in the exponent, oh, I just rewrite it like this. So literally, I'm going to take this right here. Can I just copy this part? Yeah. I'm going to copy this. I'm going to see if I can be slick so I don't have to do this again. So I'm going to copy my notes right here. See if it does it for me. Nope, did not fit. Oh, it did. It did do it. Okay, come on. Wait, is it taking the whole? No, it's not. Hold on. Let me take this whole thing. Move some stuff really quick. Nope. That's horrible. Let's try putting it over here. Yeah, that's what I want. Okay. Come on, let's go down here. Sorry, this is the only slick way I can do this without having to write it all over again. All right, so when we get over here to our function, we're going to be using this definition. So this is definitely something that needs to appear on the top of your notebook for those of you who are paper writers like me, or at the top of your page so that you can really make sure that you understand this. Here we go. I think it would have been faster for me to just write it down, but oh well. Okay, so over here, so you're saying, Ms. Johnson, this is this side, and now you write this side, So first, just write h inverse of x. You write your log. Okay, here says I need a base. That little a guy is your base. Where's your base here? Where's your base here? A is a, which matches with 10. So if you can imagine me like shifting this over and putting this on top of each other, a would be 10. Okay, so make a little a, Ms. Johnson. Yes, make a little a and push him down like he's subscript, right? Sub, like submarine underneath, right? And then you don't put B here. B is the other guy. Yes. So in this case, we're just going to use X because that's that. But instead of putting A there, we're going to use this base here, which is 10. So I'm going to erase that A and put 10 instead. Ms. Johnson, is that it? Yes. This is also known as AKA log X. Ms. Johnson, did I have to put a 10 there? No, but only for 10, right? It only works for base 10. Just like here for square root land, like when you're looking at square roots, right? You don't have to put a little 2 here because it's automatically there. So log base 10 is automatically there in log. Does that make sense? So if you have a TI calculator, when you see it, it says log, they're using log base 10. And log base 10 makes sense because our numbers are in base 10. So that's the most popular base we will use until we get to later, which is natural log. Okay, so here's your answer. I'm going to show you really quick. Ms. Johnson, I want to check to make sure that both of these two, the log, the h of x, they're inverses by the graphing technique you've taught me. Awesome. I'm just going to use this one because we already have this done. So I'm going to put 10 here. I'm going to put 10 here. And do those look like mirror images of each other? And you're like, I don't know, Ms. Johnson. So then turn on y equals to x. Oh man, that does look really good. Does that make sense? Yes, you can check this algebraically, but because you're not comfortable using logs yet, it won't really like pop out at you. Like over here, it popped out at you, right? That this plus 7 minus 7 canceled. This 3/2 and the 2/3 canceled, right? They like undid each other. They inversed each other. Okay, someone asked, Ms. Johnson, how do we add a square root symbol on Desmos? 2 ways. Number 1, it's right here. So pull your keyboard up, and then it's right here in square root. Right? The shortcut that I use is I type SQ, oops, that's not an S, SQR, and then if I put a T, it'll automatically show up on the thing. On the assignment. Yes, SQRT will work. SQRT. So if you look right here, the moment that I click T, it'll do that. The other way that I do it to get it into my assignment, just so that you guys know, you can copy from Desmos to Desmos. Like if I wanted this gnarly looking thing in there, actually here, log base 10. If I wanted the log base 10 in there, I'd copy this like this, so Control C. I'd bring it back over here to, I'm just going to pretend that I'm someone. And then I click in here, and then I'm in the math section. Don't be in text. If you click on text, this is what it actually looks like. These are the keyboard strokes. That's behind the scenes. So for those of you who like coding and stuff, this is it'll look like this. But if you take that same thing into the math structure, this is the math structure, and you paste it like Control V for me, because I'm not a Mac, it'll look like that. It'll look how you want it to look. Makes sense? Okay, I'm going to pause the recording really quick. There it goes. Okay, so we are continuing on. The next question was retrieval problem 2 and slide 13. So slide 13, I did. Retrieval problem 2 is all the way down here. Oh, no, it's up here. Sorry, my bad. It says, in this lesson, we learned that inverse functions operate operations. Oh, okay, they just want you to now check. So this is you plugging this into here and this into here. So it's that vice versa thing that we did earlier. So this is probably going to be the last problem before I end it, and then I'll pick this up. If you still have questions on those, I'll put another thing up so that we can review before a quiz. So if I'm checking f of g, so f is my outside function. Because f is my outside function, I'm going to copy f first and then leave a little blank for my x, right? So big -2 parentheses plus 3 close over 6. So Ms. Johnson, why did you add this extra set of parentheses inside? Because that's where I'm going to put my g of x. That's where I'm going to put my g of x. So I'm just going to plop him into here. So I'm going to take him and plop him right in here. And so I get 6x over -2 minus 3. And hopefully you're starting to see this little pattern. Like, I know that you guys are good at this, but don't do I don't know, my students get a little like slash happy, right? Like, oh, Ms. Johnson, this cancels, and then this cancels, and then this cancels. It's actually in order. The 3 that I said, -3 plus 3 is 0. Those would cancel. And then next would be 2 divided by, is that -2? Oh, this is a -2 and a -2. They divide and they cancel, and it becomes a +1. And then last but not least, that 6 divided by 6 is just leaving me with just an x. So far, so good. Okay, so far, so good. And then I'm going to do vice versa. I'm going to use g as my outside function. So this is going to go over here. So big G, like big G. So I'm going to go 6 big parentheses over -2 minus 3 And now I'm going to stick this F into my G, right? I'm going to plug F into my G, right? So then I'm going to write that in there. So that's -2 parentheses x plus 3 close all over 6. And again, you can kind of see how they're canceling each other out, like the 6's and then the -2's and then the +3 -3, leaving me with x. Check. So you should now know that because f of g, and sometimes math people call this fog, because fog is equal to gof, which is equal to x, they simplify to x. This means, this is the big sentence, and I'll type it here. This means they are inverses of each other. And you just checked that algebraically, right? Ms. Johnson, were we supposed to write that? No, I'm just telling, oops, that's not what I wanted to do. Thank goodness for Control Z. Okay, shadow. Okay, so Ms. Johnson, why did you write that? Because now you should know that that's what that implies. This means that they're inverses of each other. Boom, done. Okay, so let me stop recording.